And it is the one that you absolutely have to know how to do.
Okay.
If you know anything from this parameters and polar section, it's how to find dy dx when you have two parametric equations. So what's dy dx equal to?
Dy dt over dx dt.
Tell me what dx dt is.
Dx dt is 3t minus 1.
Squared.
Squared. Yep.
Now, you do have to apply the chain rule there, but the derivative of the inside is 1.
Right.
Okay. What is dy dt?
Dy dt would be 1/2 t to the negative 1/2. So 1 over.
Yeah, we can leave it like that for the moment.
Okay.
Now let's plug it into that. So we have 1/2. Here, let's do it over here where we can see it a little better. 1/2 t to the minus 1/2 divided by 3 t minus 1.
Squared.
Squared, excuse me. Now, if I simplify all of that, doing algebra, what do I have?
Well, would we multiply by the reciprocal?
Well, I do it piece by piece. Let's deal with that. That means that 2 goes in the bottom.
Yeah, so it'd be 6 on the bottom.
Okay. Let's just do it like this. Now, what about the t to the minus 1/2?
T to the minus 1/2 would go down to the bottom as the square root of t.
Exactly. So what we're going to be left with is 1 over 6 t minus 1 squared times t to the 1/2, which is, I'll just leave it as t to the 1/2 for the moment. So that is our answer. Now let's see if we can find something that looks like that. Right there, B.
Yep.
Okay. So that was really straightforward. Is all you got to do is remember that first equation.
Right.
Okay, let's go up to number 11, which I believe is the next easiest. Well, I don't know about easy, but this is a calculator section, right?
Yes.
Okay. So the first thing I did was graph it in Wolfram Alpha. I'm sure you could do the same thing in Desmos.
Okay.
But it's x equals cosine of theta, y equals 2 sine of 2 theta. And if we look at that curve, they're asking for where are the points of horizontal tangency. In other words, where is the slope of the tangent equal to 0?
Right.
Well, we can see 4 points there. Obviously that, hold on. And I'm showing you this not because you need to see it, because I'm going to go through the mathematical part also, but there are clearly 4 points where the tangent line is horizontal. And in fact, what we're looking for, notice this is a graph of x versus y. Even
Right.
though these are represented by parametric equations, the theta doesn't really show up yet, not in the graph, because we didn't see it traced. If you see a graph get traced from the beginning to 2 pi, then you kind of see it in action.
Right.
But nonetheless, we feel like there should be 4 points of tangency. So it's a little tricky, but this is, I would say, the next thing you need to be able to figure out how to do. Okay, so again, I have 2 parametric equations, just like 12. Only these are parametric equations in theta. But I still need dy dx. It's the best place to start here. Can you read that over on the right?
Yeah.
Okay. I had a student the other day and he couldn't see the right side of my screen. And I wondered if maybe it wasn't because he had the GoToMeeting control panel fully expanded, which you don't need to do. You can always minimize it. Have I talked to you about that?
Yeah, mine's the little bar on the top.
Okay. You've already minimized it. Good.
Yep.
So here, what is dy dx equal to?
Dy dx equals to dy over d theta over dy dx d theta.
Correct. Okay, so what's dx d theta?
Dx d theta is negative sign of theta.
And what is dy d theta?
Dy d theta is cosine 2 theta, 2 cosine 2 theta times 4 sine of 2 theta.
No. In other words, the derivative of sine of 2 theta is cosine of 2 theta times 2.
Okay.
And times the other 2, you get 4.
Okay.
So that's what the derivative of y is. Plugging all of that in, I got 4 cosine 2 theta is this, divided by negative sine of theta, which is that. And what do I want? I want to know where that's equal to 0, right? In other words, that's the game in calculus, is you take the first derivative, you set it equal to 0, and you find all horizontal tangent lines. So, now with parametric, there is something else you have to be careful about. So that's what I'm doing.
Okay.
Now, what makes that ratio equal to 0? The numerator. The numerator has to be 0, right? In other words, no ratio is equal to 0 unless the numerator is equal to 0.
Right.
Okay.
Because if it's if the denominator is equal to 0, it's undefined.
Exactly. That's the only case you have to worry about, is if both the denominator and the numerator are equal to 0, then you don't know what you're looking at. You don't know if you're looking at a horizontal tangent line or a vertical tangent line. If the denominator is equal to 0 and the numerator is not, then you're looking at a vertical slope line, right?
Right.
Vertical lines are undefined, and undefined is where you're dividing by 0. You're dividing a number by 0.
Mm-hmm.
So as long as dy d theta and dx d theta are not both simultaneously 0, then there won't be any problems here. We'll be able to find all horizontal tangent lines and all vertical tangent lines. they've only asked for horizontal. So the only thing we need to solve is for the numerator, and we need to maybe check and make sure that denominator is not 0 also, but it doesn't figure to be. So now I'm going to divide both sides by 4. Cosine of 2 theta has to be equal to 0.
Right.
So 2 theta has to be equal to the inverse cosine of 0.
Okay.
Right? That's how you solve trig equations. Well, where is that the case? In other words, theta, notice that if theta were pi over 4, then 2 theta would be 2 pi over 4, and the cosine of 2 pi over 4 is 0.
Right.
So that's one solution.
Okay.
Likewise, 3 pi over 4, if I plug that in to here for theta, multiply it out, I get 6 pi over 4, which is 3 pi over 2. Cosine of 3 pi over 2 is also 0.
Okay.
So that's also a solution. Turns out that within the unit circle, there's 2 more solutions.
Okay.
You plug those last 2 in to cosine of 2 theta, you'll find you get 0. So here are all of the solutions inside the unit circle.
Right.
Now, how do we take this information for theta and figure out what these points are?
Will we plug them into dy dx?
Not dy dx.
Or
We know what theta is at these points that we saw in that graph. We know theta is pi over 4. It's one of 4 points. So let's go back to the original equation. X equal cosine of theta, y equals 2 sine of 2 theta. Let's figure out what the x coordinate is when theta equals pi over 4.
Okay. So cosine of pi over 4 is
45 degrees.
So that'd be root 2 over 2.
Correct. But the most direct thing is 1 over root 2.
Right.
This has to do with whether or not they draw this triangle. You can label it 1, 1, root 2, or you can label it root 2, and 2.
Okay.
And they tend to like this labeling because it rationalizes the denominator with most trig functions. Whereas if I use the 1, 1, root 2 triangle, I get an unrationalized denominator. Well, nobody cares anymore whether you have an unrationalized denominator.
Okay.
And that's because in trig, you're frequently dealing with the reciprocal, right?
Right.
In other words, if cosine is 1 over root 2, then secant is root 2 over 1. So rationalize it can take you backwards if you have to work with its reciprocal. So for the last 3 or 4 years, every trig teacher that I've dealt with, or every student, has said, yeah, they're no longer making us rationalize it. And clearly here they don't. All of our answers are 1 over root 2.
Right.
What's y equal to?
Y at pi over 4?
Uh-huh.
So 2 pi over 4, which is pi over 2. Sine of pi over 2 is 1/2. No, sorry. 90 degrees. So 1.
Yeah. There's a couple ways to learn that. Let's just review it. The easiest way to really learn it is to look at the unit circle. Okay, pi over 2 is that point right there, right?
Right.
What's the coordinates of that point in the xy plane?
0, 1.
Okay, and we know that this point, the left point is cosine of theta,
Right.
and the right point is sine of theta. So whenever you're trying to figure out what the sine of 90 degrees is, this will tell you. It's 1. If I go to this point right there, which is 180 degrees, I've got the coordinates are minus 1, 0. So what that tells me is the cosine of 180 is minus 1, and the cosine of 0, or the sine of 0, is 0.
Right.
Okay? So this unit circle thing will always answer those key questions. Now,
Okay.
the other way is just to memorize that curve, which might be a better way. Because that's 1, that's minus 1, that's pi over 2, that's pi, that's 3 pi over 2, and that's 2 pi. And you need to know this anyway, right? I mean, you got to memorize that sooner or later in trig.
Right.
And if you memorize the cosine curve, then you can immediately figure out when I'm trying to remember what the cosine of 180 or 270 is, I always refer to these curves rather than the other way, the first way that I told you.
Okay.
Just because these curves are locked in my memory. So it's not hard for me to come out and figure out what the cosine and sine of these quadrangles are. Quadrangles being multiples of 90.
Okay.
Okay. So there's a point right there that looks like it's our answer.
Right.
That was just for pi over 4. I had 4 points. So what
But
that
that's also
tells us,
A.
yeah, what that tells us, in other words, we could do the math, but we don't need to. If you look at the curve, the point we just figured out was this one right here. That is 1 over root 2, 2. Right? Now,
Right.
1 over root 2 is actually a little harder to figure out what that number is than root 2 over 2. Root 2 over 2 is 0.7, right?
Right.
There's your 0.7. And the y coordinate, there's your 2. Okay? So we found 1 point based on a t of pi over 4.
Okay.
Well, clearly symmetry is at play here. Can you give me the coordinates on that point?
So then that would be negative.
Hold on, x coordinate didn't change.
Yeah, 1 over root 2 and then negative 2.
Okay, how about this point?
Negative 1 over root 2, negative 2.
And finally this point.
1 over, negative 1 over root 2, 2.
That's these 4 points right here. Number C.
Sweet.
Now, notice that if you were really clever and you graphed it, you can tell that there are 4 points there, right?
Right.
In other words, the answer cannot be there are no tangents, there are no horizontal tangents. In other words, I can answer this problem without doing all that math. I wanted to go through the math because I think it's important you know how to do it. This is a very, very common question with this subject, is finding horizontal tangency. So just by looking at the curve, we know that's not true. We know this isn't true because we can see there's 4 points. That's an angle measurement.
Right.
Not what they're looking for. They're looking for an XY coordinate points. So this one has 4 points, so it's either C or E. We've ruled out the other 3. And since we know that there are exactly 4 points, if I had to bet money, I'd guess C, even without doing any of the math.
Okay.
Okay? So it's just a clue. You may find yourself with a problem like this and running out of time and you don't have time to do the math. It's like the SAT test. You take the answer that's most likely. All right, 10. Going backwards. I'm not sure why. I went forwards through these the first time, but 10 is pretty easy. I want you to give me, it's not that different than anything else we've done, so you help me.
Okay.
We're looking for, this time we're looking for the equation of the line tangent.
Right. So we would find dy dx first. And dy dx equals dy dt over dx dt.
Okay, what's dy dt?
Dy dt would be 4t cubed plus 4t.
And dx dt?
And dx dt would be 3t squared plus 1. So then,
now it's relatively clear. They didn't give you anything in x and y. They said, what's that equal to at t?
So then we just plug in 1. Okay. So that would equal...
So dy dx is going to be equal to what?
8 over 4, which would be 2.
Now, this is the tricky part. Once you have the slope, what equation are you going to use to come up with the equation of that line?
Well, we'd have to plug in 1 for t for each equation to find the x and y points.
No?
To plug in.
No, I don't think so. No. Use the point slope format.
Would that be y equals mx plus b?
No.
Or no?
This is, once you get to calculus, you'll notice that most of calculus was point slope format. And the reason is that you have a point and a slope. Whereas the y equal mx plus b, you need a y-intercept. Well, we don't have a y-intercept here. We have a slope for sure. Now the question is, do we have a y sub 1 and an x sub 1? Well, we don't have yet, but we can certainly come up with them when t is at 1.
What's the equation that's y equals y1 plus or minus m times x minus x1? Is that the same thing? Just a different thing?
Yeah. The way to remember the point slope formula is to divide both sides by x minus x sub 1. Then you're looking at m equals y minus y over x minus x.
Okay.
Okay? But it's only 1 point. This is called point slope format because we have exactly 1 point and we have a slope. Well, what is our 1 point? What's x? X sub 1. Well, let's start with y sub 1. Y minus, what's y sub 1 when t is equal to 1?
What's y sub 1? Oh, okay.
In other words, y is equal to
3.
Okay. Equals the slope, which we've already calculated to be 2.
Times x minus 2.
Okay. Now, I don't know why they did this, because it's not in the thinking of calculus. This should have been one of the answers.
Right.
In other words, you don't use y equal mx plus b in calculus very often. You always use point slope. So when you come up with the answer in point slope format, that's the answer. However, that's not on there of the 5 choices. So the only thing we can figure is they simplified. Okay? Well, if you simplify this thing, get this, and then you get y equals 2x minus 1. That answer is on there.
So that would be A.
Uh-huh. But like I said, I don't know why they didn't, in their multiple choices, give you point slope. Maybe because it would have been a clue. If you look at all the answers and they're all in point slope format, then you figure out how to do the problem. In other words,
Right.
Figure out how to come up with the equation of the tangent line. Now, coming up with the equation of the tangent line is a classic problem, whether you're in parametric equations or regular equations. You always come up with the slope, plug in the one xy point you know, you got your equation. Simple as that.
Right.
All right. Other one is 9. This one gave me fits. We got 3 minutes. I got enough time to do it, I think. Let's see. Hold on. R equals 2 sine of 4 theta. R equals 2 sine of 4 theta. R equals 2 sine of 4 theta. That's the way you have to put it in on, what happened here? R equals 2 sine of 4 theta. Now, notice it gives me the right equation, and notice what else it did. It plotted it in the x. That's an equation just like y equals 2 sine of 4 theta. You could plot it on the xy coordinate plane like this. You with me?
Yeah.
It also happens to be a polar function. And the fact that I used R, Wolfram Alpha was smart enough to realize that it could be polar, so they show us the polar plot and the XY plot.
Okay.
This is one case where they're different. A lot of, when you're not dealing with parametric equations, you can put the polar plot on the same piece of paper as you put the XY plot. And the points can overlap. But once you introduce parametric equations, it becomes completely different. The XY plot, or I should say the R theta plot, which is the second one, is not the same as the polar plot, where theta goes from 0 to 2 pi.
Right.
Okay, the secret, there is a formula for the area, which says the area of a polar curve is equal to 1/2 the integral of the function squared, r squared d theta. With me?
Yep.
From some angle to some other angle. And therein lies the problem, is figuring out those angles. Now, they want the area of just one leaf.
Right.
So, that leaf starts at 0. In other words, if you plug in 0 for theta, you get r of 0. That's that point right at the origin. You with me?
Yep.
If you plug in pi over 8 for theta, you get this point, 2. Well, 2 on a polar plot is that length of that distance from the origin to the end. So this thing appears, well, I can't tell really for sure, but it appears to be going like this.
Right.
Now the question is what is that radial line? In other words, we know that alpha is 0. Well, it took me a long time to figure out that this one had to be pi over 4. And I think you can see why. If you look at symmetry, so that's what the upper limit is. Pi over 4. And what that means, just in case you're still not quite up on polar, is that I'm going to start there and I'm going to rotate it to there. And I'm going to get the area by inputting that, squaring it. So the area should be 1/2 the integral from 0 to pi over 4 of 2 sine of 4 theta squared d theta. Now, the one really important thing you need to be able to do, and if you can't do it yet, find out how, is to take this integral on your calculator or somewhere that you're going to have when you take a test.
Yeah, I can do it on my calculator.
Because this is not the easiest integral to solve. It can be done. But from what you've told me, they did not ever teach you integrals of, did you ever get these? You told me no once.
No.
Okay. That is a pretty huge subject. That's like a few days worth of class time to figure out how to do those. And in order to solve that integral manually, we would have to know all about them.
Okay.
Okay? So I went through it, and I know how to solve it, and I did, but I couldn't get one of the 4 answers on the test. And also, I can't figure out how to do integrals on either Wolfram Alpha or my TI-84 is, the batteries are gone, and it won't, even with new batteries, it won't boot up. So I don't have one of those, and I can't figure out how to do it on my TI-Inspire. But if you can figure out how to do it, go ahead and do it. And whatever answer it gives you, hope to find that on the multiple choice, and that's the correct answer.
Yeah, I have the TI-84 plus CE.
Okay.
So it's the newer version. It's got the LCD or LED screen.
Oh, really?
Yeah, so it's not dark, so you can actually see what's going on.
Does it allow you to input exponential functions where you, in other words, do you have to do this?
No.
Can you do this?
You just raise it to the power.
Oh, that's
like,
wonderful. That's huge. Because some of these functions in there with parentheses and double parentheses and triple parentheses is tough sometimes. Especially
yeah, it's pretty
on the TI-84 because they don't show you your input. It's the one thing I love about Wolfram Alpha is they actually show you your input.
Yeah, it's easy on the TI-84 plus CE, the newer one.
And you know how to solve an integral like this?
Yeah.
You can take the definite integral and put in the limits of integration.
Yeah.
And it should spit out a number.
Yes.
Hopefully that number will be one of these 4 numbers. Pi over 12, pi over 6, pi over 3. I kind of think it's pi over 2. I think when I did it, I was off by a factor of 2. I think I got pi. And it's really easy to get off by a factor of 2 in these kind of problems when you're doing it manually. Unbelievably easy. So the easiest way is just not to do it manually, do it on your calculator.
Okay.
Okay? Sorry, I've kept you a few extra minutes, but
It's all good.
it's actually pretty good. This is a good page for learning about polar and parametrics and slopes of tangent lines.
Right.
And areas. So,
yep. Thank you.
You canceled tomorrow's session, is that right?
Yeah, I canceled it. I'm leaving for Florida on Saturday morning, so I just didn't have time.
That's fine. You going down there to play baseball?
Yeah, we have our spring training now.
That sounds fun. Oh, that's over your spring break here. So, wow. Hope you're in shape. Well,
Yeah.
you could be after just coming off a hockey season, I guess, huh?
Yeah.
So, all right. Well, good luck. Have fun. And I'll talk to you when you get back.
Okay. Thank you so much.
All right, John. Bye-bye.
Bye.